Since touchscreens are so common in today's society, we thought it would be interesting to learn how they work. At the most basic level, there are three systems that can register a person's touch: resistive systems, capacitive systems, and surface acoustic wave systems. The resistive system has a typical glass panel, and that panel is covered with a metallic and conductive layer. There is also a scratch-resistant layer. When the monitor is turned on, there is an electrical current that runs between the two layers, so that when the user touches the screen at a certain spot, the layers make contact in that area. When the location of the touch on the screen is known, the location is translated so that the operating system can understand what needs to happen, which is similar to what happens with a computer mouse. An example of this is the ATM machine. For capacitive systems, instead of two layers, there is one layer that stores electrical charge. This layer is placed on the glass panel of the device. When the user touches the screen, some of the charge is transferred to the user, and there are devices that measure the exact decrease in charge. Then, the location of the touch can be calculated based on where the charge decreased, and that information is then relayed to the touchscreen driver software. There are advantages to the capacitive system over the resistive system. The capacitive system transmits around 90% of the light from the monitor, whereas the resistive system only transmits around 75%. This means that the capacitive system gives a clearer picture than the resistive system does. Also, the capacitive system registers only a conductive input, like your finger, but the resistive system registers any touch that creates contact between the two layers. The last system is a surface acoustic wave system. In this system, there are two transducers which convert a signal in one form of energy to another signal in a different form of energy. One transducer is a receiver and one is a sender, and these are placed as the x and y coordinate axes on the screen. There are also reflectors on the glass panel, which reflect the signal from the two transducers. When the screen is touched, the receiving transducer can determine the location of the disturbance. Unlike the other screens, there are no metallic layers, which result in a 100% clear picture on the screen. One last thing to consider is the cost of these systems. The resistive system is the least expensive, since it has a lower picture quality, and it is easier to damage. The surface acoustic wave system is usually the most expensive of the three systems.